Welcome to biology. This is your summer assignment. I am Mr. Dutton. I am one of the science teachers at Campus International High School. For your summer assignment, you will need to log into Google Classroom. The class code for biology is BDUE3JI. Once you're on Google Classroom, you will see that there's a link to the summer assignment, Icy Summer Science. What it involves is you doing an experiment. It's a pretty straightforward experiment involving a fundamental question, which we do in the sciences all the time, is we ask a specific question, and then we determine what the answer is by collecting some data and coming up with a procedure in order to evaluate that question. So the question that I'm posing to you for the summer is, which surfaces cause ice to melt the fastest? Right? And you probably already have an idea about what kinds of surfaces would cause ice to melt faster. That it would have something to do with maybe the color of that surface, maybe the temperature of that surface, maybe if that surface is in the sun or that surface is in the shade. There are lots of different ways that you can approach this and you can think about it. What I want you to do is I want you to find at least 3 different surfaces to test on a hot day. I do want you to test on a hot day because I want you to not be sitting out there waiting for that ice cube to melt for hours, or maybe not hours, but at least for too long, right? On a hot day, the hotter it is, the quicker that ice cube is going to melt. But I want you to find surfaces that are as different as possible. For example, you can look at dark and light surfaces. You can look at surfaces that are smooth, surfaces that are rough, pavement, grass, different materials like metal, putting it in a glass of water. All of those things would be different surfaces. So that's how I want you to test. Now, I did say find at least 3 different surfaces. Science always improves. Data analysis and conclusion always improve based on having more tests, based on more experimentation. Make sure that on the document on Google Classroom, make sure that you describe those surfaces so that it's clear what surfaces that you have chosen. All right, so just an idea of, hey, we're talking about ice melting, and what I want you to pay attention to is when we talk about that ice melting, you notice that these ice cubes are all different from each other, right? You want to make sure that all the ice cubes you use are as similar to each other as you can get them. I have seen people use like egg cartons as ice cube trays because when you do that, then you can make sure that they're all the same size. You know, if you don't have an ice cube tray, there's like I said, the egg carton or a variety of different things can be used. Don't freeze anything in glass because if you freeze something in glass, you run the risk of making that thing that's in the glass explode. Glass does not expand and contract. And water, when it freezes, it expands. So you don't want to put water in the freezer inside of anything that can't expand. So what do you need? Well, you need ice, obviously. And it would be helpful to have a phone or at the very least some sort of stopwatch and a camera. I do want you taking pictures. So make sure that you have some way to take pictures of this so that you can submit those pictures. We want to collect all sorts of data, not just the time, but we also want the visual data because sometimes that tells a better story than just the words that we can put on paper. So for each trial, I want you to put 1 ice cube on the surface and time how long it takes for the ice cube to completely melt. So as best as you can, determine that moment when that last tiny little bit of ice has turned into water. Right? I want you to take pictures of every trial. You don't have to take pictures of like, you know, every minute, every trial. If you just have a picture at the beginning of every trial, that'd be fine. Or if you want to have a picture about midway through, when some of it is melted and some of it is still ice, that also might make sense. And follow at least the rule of 3. Perform the experiment on each surface at least 3 times, and make sure you have at least 3 surfaces. So when you do that, before you do that rather, you're going to make a prediction about which of those surfaces are going to cause the ice cubes to melt the fastest. And make sure to include a reason why. Okay, that reason why cannot be because I think it's going to melt faster. Include some sort of scientific reason why. Is it because that surface is darker? Is it because that surface is hotter? Is it because you think that more sunlight will get absorbed by the ice cube on that surface for some reason? Does it conduct heat faster? Maybe it's not in the sun right now, but the sun is coming out. Come up with some reason why that surface is going to cause the ice cube to melt the fastest. So when you collect your data, and I'm going to show you a data table in a minute here. When you collect your data, I want you to present your results in a data table. So I'm talking about numbers. I also, as I said, I want you to take pictures, and I also want you to write about it. So write about what happened. Just take notes. Right? It doesn't have to be formal, doesn't have to be a paragraph. Just take notes about what happened during this experiment, especially anything that you weren't expecting. In your analysis, I want you to explain which surface melted the ice the fastest. And by doing so, you are analyzing the data. You are using the data to tell a story about which surface melted the ice the fastest. And so by analyzing any trends, any patterns in the data, you will then be able to say, oh, it turns out the pavement melted the ice the fastest. And because, and then coming up with some supported reason why. And then your conclusion, go back to your hypothesis. If your data agrees with your hypothesis, then your hypothesis was supported. If there is a conflict between your data and your hypothesis, that means your hypothesis was not supported. That you could also say that your hypothesis was rejected, but you never say your hypothesis was wrong. And you never say that your hypothesis was right. Here's why. Is because there's not really a right and wrong. Your hypothesis could be supported by the data, but you don't know yet whether or not it's actually correct. All you know is that in this experiment, your data shows that that hypothesis was supported. There was data to support your hypothesis. All right. If you do the experiment 100 times in 100 different scenarios, you might then get to the point where you can say, yeah, I think my hypothesis is right. That's where we actually start to form what are called theories. I'm not asking you to form a theory. That's why I'm saying all you should say is whether your hypothesis is supported or not. All right, that's it. And if you say my hypothesis was completely wrong, you don't have enough data to say that yet. All right, you would have to, again, you'd have to collect a lot more data. You'd have to do this 100 times in 100 different scenarios to be able to say, you know what, that hypothesis is just wrong. There's nothing right about it. So it's a really fuzzy line, and that's what you're going to do for your conclusion. Here's a sample data table. In this experiment, I did 3 different surfaces. We see those are the columns. And for each surface, I did 3 trials. I measured in seconds, and I made sure to note that in the upper left-hand corner. I also gave every measurement units. Notice I didn't say 190.1 seconds. And in fact, not only did I not include a decimal point, but you see that everything is rounded off to the nearest 5. Now, you don't have to do that. You don't have to round it off. You could say it was 192 seconds. You can say it's 256 seconds. The reason I'm saying that and I'm rounding it off to the nearest 5 seconds, is because determining that moment when the ice cube completely melts can be a difficult thing to do. You're like, I think it's all melted, and you keep watching it and you verify, you say, yes, that's all melted. Here's the time. It's within a few seconds. And so that's why I rounded off to the nearest 5 seconds. You may even want to round it off to the nearest 10 seconds. You may be waiting so long, you're like, it was 10 minutes, and you leave it at that. And that's okay as long as you're consistent. As long as you don't have some data that says, oh, it was 5.6 seconds, and some other data that says, well, it took 25 minutes. You have to be consistent. If you're going to round off to the nearest tenth of a second, you have to round off to the nearest tenth of a second for all of your data. I think it's wise, given this particular experiment, to round off to the nearest 5 seconds. Finally, and I've talked a lot already, but if there's anything in this you didn't understand, if I went too quickly, if you have any other questions, anything I didn't talk about, feel free to message me through Google Classroom with any questions you have. A lot of you already have my email address, john.dutton@campusinternationalschool.org. So feel free to email me or message me. And a word of advice: the earlier you start, the more likely it is that I can help you. I look forward to meeting you. Stay safe and stay healthy.